Hello, grade 11 students. This is your teacher in Earth Science for week 2. As you are well aware of, we are still in lockdown, so we could not give you your module for week 2. So instead, I have prepared this video with a presentation so that you'll be able to learn the lessons in week 2. Are you ready? Welcome once again to our class for Earth Science, this time on week 2. By the way, I am your teacher. I'm Sir Stephen Tabal. And for our activities, just send to me your files through this email, stephen.tabal001@tibet.gov.ph, the same file name, but this time you put underscore week 2. So before we move any further, let us first review the do's and don'ts in our online class. Okay, that's it. Here's a famous quote from a person we don't know, but according to that person, science today is the technology of tomorrow, and I hope that will be your guiding light in dealing with this pandemic. Our lesson for week 2 will focus mainly on mineral versus rock. So we have 4 questions here that you need to answer on your own. 1. Is mineral and rock one and the same? 2. Can a mineral be a liquid form? 3. Is it made of living material? And 4. Can it be man-made? So pause for a while and try to think the answers to these questions, and we'll be able to know better mineral, and eventually we'll compare it with rocks. To identify a mineral, we have 5 criterion for us to identify. The first criterion is that it must be solid. So something in liquid form is not a mineral. Second, it must occur naturally. It's not man-made. So you cannot call something as mineral to its made from the lab, so it should be naturally occurring. Next, it is not made of non-living material. It is made of non-living material. It could never be alive, so it should be non-living thing. It should have a definite formula like salt, sodium chloride, and finally, it should have a crystal structure. So, if the five main criteria is present, then you can simply say that it is actually a mineral. You might have an idea already of what is a mineral because it's very common to every household. For example, copper. Usually, they are used for electrical wiring. So, in your household, if you have electricity, then the wires used for that is made of copper. Gold, diamond, silver, they're usually used for jewelry, platinum for other materials, and they're very common as well. Talc is a mineral used for cosmetics, especially powder for kids. Quartz, graphite, halite, kaolin, and barite. These are common applications of these minerals that you will encounter in your daily life. To identify a mineral, you need to check first the physical properties, especially for geologists. If they go to the field, they cannot bring with them sophisticated equipment. So instead, they will look at the physical properties to identify what kind of mineral they are dealing with. So these are the physical properties of a mineral. Like one, that's crystal form, second, luster, third, color, four, streak, five is hardness, six is cleavage, and seven, we have fracture. Let us discuss briefly one by one. Let's start with crystal form. You can read with me if you want. It is the external expression of a mineral that reflects the orderly internal arrangement of atoms. For example, sodium chloride, or better known as salt. If you look at closely, using your naked eye, you cannot identify exactly the shape, geometrical shape of a salt, a fine grain. But if you look at salt, one particular speck of salt, then it's actually cubic in nature. That's why if somebody steps on it or kneels on it, it will be quite painful. So that is its crystal form. But like here, the pyrite and quartz, they might look very perfect because it's quite cubic in nature, and quartz has this crystal form. But not all of the minerals are like this. Some might have a regular shape, and some would come up with a very sophisticated shape because of its internal arrangement of atoms. So, geologists can now identify what kind of mineral they're dealing with by looking at its crystal form. Second one is luster. Is the appearance of a mineral when light is reflected from its surface. For example, a white t-shirt appears to be like reddish in color if the color is red as its light source, and it appears to be blue if the source of the light is blue. So mineral could also be like that. When they're exposed to a source of light, it will vary in its color, depends on the kind of mineral they are you have. So the light could appear different color depends on the light source or could be upon its reflection. So you can divide the two mineral in terms of luster as metallic and non-metallic. So when it's metallic, it shines like a metal, but for it's not non-metallic, it could be like shiny, glassy, or earthly in nature. Second one is color. The color is the most obvious feature of a mineral, but often it's unreliable because uh, if the light source is not that well, then it might reflect a different color, so it's not that reliable. But it's also the simplest physical property that geologists often use. But again, let me stress that one out, that it's not reliable. For example, we have sulfur, it appears to be yellow, but you cannot be so sure that it's sulfur unless you do another test. So that's why streak comes in. Because in streak, you need to get the color of the mineral when it's in powder form. So you can do the streak test by scratching the mineral on this particular streak plate and the real color comes out. Hardness. It refers to the measure of the resistance of a mineral to abrasion or scratching. One with a higher value in hardness, we call that one Mohs scale, can scratch a mineral with a lower value. For example, diamond can scratch 1 until 9. That's for hardness. And we also have cleavage. Cleavage is when it breaks, it cleaves, or it will break parallel with the planes. So it will result into a smooth surface. You need to use a hammer as a tool and it will break in planes. So in that way, you can also identify what kind of mineral you are dealing with. Like in this case, 3 at 90 degrees or 3 not at 90 degrees depends on the cleavage. On the other hand, we have also what they call fracture, wherein it doesn't exhibit cleavage when it's broken, but it's like a rough surface. So in that case, like quartz, it has a fracture. It's not a cleavage. So at this point, I want you to search this one in the net or in books and identify, just write it this one in your notebook or in band paper, the, the 8 elements that make up more than 98% of Earth's crust. And I want you to list them from one being the highest in the makeup to the one being the lowest. So for your task for this week, since it's still part of the lesson, I want you to compare first rocks to minerals. And when you're done, you come up with the rock cycle, but be creative in your performance task. Come up with a video, a short video perhaps, or a PowerPoint presentation, but you need to use creative approach. Or you could come up with a hand paint if you want. Just be creative for as long as you'll be able to identify the difference between minerals to rocks, and at the same time you'll be able to show the rock cycle. So reminders for this week, you need to finish week 2, and for next week you'll be working on week 3. Just answer all the questions found in the soft copy of module 2, and if you have more questions, just PM me in Facebook or you can send me an email to the address that I gave you a while ago. If there are no more questions, then that's all for now. See you soon. Bye bye. Thank you, grade 11 STEM.